In this class, now I am going to explain you properties of tangent of a parabola. So before going to the properties of tangent of a parabola, now I would like to explain you one problem from parabola. Let us see that. Okay, see here, find the length of the chord which is intercepted by a parabola y square equal to 4ax on y equal to mx plus c. See, this is the curve of this parabola y square equal to 4ax. Now, this is the given line equation. In the problem, one curve equation is given, that is parabola y square equal to 4ax, and this curve is intercepting. So on this y equal to mx plus c, so that portion is here a to b. Now here we have to measure this chord which is intercepted by this curve. Okay, so find the length from a to b. How do we find? So let us assume the coordinates of this a are x1 comma y1 and coordinates of b are x2 comma y2. So if 2 points are known to us, how to determine the distance from a to b? You know. So square root of x2 minus x1 whole square plus y2 minus y1 whole square units. Okay, see in the next step what I am doing. This point is there on this line now, so that here you can write y1 is equal to mx1 plus c, and this point is there on same line, so that here you can write y2 is equal to mx2 plus c. Now here in this formula x2 minus x1 whole square I am writing as it is, but in the place of y2 minus y1 I want to take the difference of these two. If you take the difference of these two, what do you get? y2 minus y1 is equal to mx2 plus c minus mx1 minus c will come. So these two are cancelled, and from these two take m common. So here x2 minus x1. Now come back and substitute in this formula. x2 minus x1 whole square plus, so here when you write this one over there, then it will become m square x2 minus x1 whole square will come. So in the next step, see students, so from both what do we take common? x2 minus x1 can be taken outside while it is coming. So here you have to write outside x mod of x2 minus x1. So inside what is left here? Whose coefficient 1? Here whose coefficient m square? 1 plus m square. Okay. So here if you know the x2 minus x1, then your problem will be finished. See, observe me how I am going to obtain this difference of x coordinates, because this a and b are not given, just we assumed. Okay. To find this length from a to b. So here find this x2 minus x1, difference of x coordinates. See, observe me how I am going to find this. So in the next step, see this parabola and this line equation, both I want to solve. Okay, so here this is the given parabola y square equal to 4ax, and in the place of y, so I want to write mx plus c. So it is coming from line equation, so which is equal to 4ax. Now it is looking like a plus b whole square. Expand it, m square x square plus c square plus 2mcx, so which is equal to 4ax. Now bring this one to the left side. M square x square, when you bring this one to the left side, here what do you get? 2mc minus 4a x plus 2, sorry here, still one more term we have to write here. Okay, this is a square. Okay, a square plus b square plus 2ab, which is equal to 4ax. Fine. Next, here m square x square. Now bring it to the left side, and so that here what do you get? 2mc minus 4a of x plus c square, which is equal to 0 you will get. Now observe, it is a one quadratic equation in terms of x. Am I right? So if you solve it, you will get two values for x. Let us say them x1 and x2. Okay. So here sum of these roots is equal to minus b by a. So minus of b value 2mc minus 4a by m square. This is the sum of the two x values which are going to obtain by solving this quadratic equation. And product of the roots x1 x2 is equal to c by a. So here c square by a, m square will come. Okay. So in the next step, see here, actually here what do we require? Difference of x coordinates of a and b, no, but here we got the sum and product. When you know the sum and product, how do you find the difference? x2 minus x1 can be written as square root of x2 plus x1 whole square minus 4x1 x2. You know this identity, so in which write this value. If you write this value over there, then you will get 2mc minus 4a by m square whole square you will get minus 4 x1 x2 4c square by m square. Okay. Alright. In the next step, here go for simplification of these two. So what do you get here? Inside of the square root, here m power 4, here m square. Total LCM is m power 4 will come, and here 2mc minus 4a whole square minus 4m square c square. So in the next step, from the numerator, see, simplify the numerator. Here 4m square c square plus 16a square minus 16mca minus 4m square c square by m power 4. So these two are get cancelled. Okay. The next step. So in the next step, what do we take common from the numerator? Here 16, here 16. Okay. Take that 16. Okay, common from the numerator. If you take 16 common from the numerator, so right, what do we get here when you take 16 common? So outside 4, inside of the square root, what is left? Square root of a square minus mca, from which you can take a common. So a minus mc. Here from these two, what I am taking common? A square common. When you take here, after cancelling these two, here 16 I took outside, here a square minus mc a left, from which a take common, a minus mc you will get inside by m square. So this is the difference of x coordinates of a and b. Substitute the difference over here. So that what do we get? So 4 by m square into square root of a minus mc into here square root of 1 plus m square is there. Finally, what will be the length from A to B? See here, simplify this. So our required length of the chord which is intercepted by y square equal to 4ax on y equal to mx plus c is this much. So here write this 4 by m square as it is here. It is looking like root A into root B, which is equal to root of AB. So A of A minus MC into 1 plus M square units. Okay, right. Now let us go to the properties of tangents of a parabola. Y square is equal to 4ax. Right, you know, see here, y square equal to 4ax. Take any one point on this parabola and draw there one tangent, whose equation we have to determine. How do we find? Let us consider this point of contact to be x1 comma y1. Okay, so generally, okay, how do we find this tangent equation? So here one of the point is known to us. We have assumed that point of contact as x1 y1. Still, if we know the slope of this tangent, you can able to find whose equation by applying point slope form of a line equation. Okay, here you do not know the slope of this tangent. Hence, how I am going to find whose tangent slope? By doing differentiation of this curve on both sides with respect to x. Do whose differentiation with respect to x? 2y into dy by dx, now which is equal to 4a. Now, okay, let us represent this dy by dx with m, because differentiation is nothing but slope of a tangent. Okay, so that I am okay, replacing this one by m. Now here 4a by 2y. So right, now 2 2's are cancel, m is equal to 2a by, substitute this point of contact after differentiation, so that here you will get y1. Okay, right, now you got the slope, you know the point. Then what is the equation of this tangent? Y minus y1, which is equal to m. M is nothing but 2a by y1 of x minus x1. Okay, in the next step, see here, bring this y1 to the left side, so that here what do you get? Y1 minus y1 square, which is equal to 2ax minus 2ax1. Okay, right. So actually, where is this point on this parabola now? Hence, substitute this point in this curve equation, so that you will get y1 square is equal to 4ax1. So here write this y1 as it is. In the place of y1 square, write this value 4ax1. So 2ax minus 2ax1. Okay, simplify, go for simplification. So okay, transfer this one to the right side, so that what do you get? Y1, which is equal to 2ax when it comes to the right side, which will come as here 4 minus 2, 2ax will come. So y1, which is equal to, from both, what do you take common? 2a. Here x plus x1 will come. When you bring this one left side, y1 minus 2a of x plus x1 is equal to 0. So this is nothing but what? As per the notations of this parabola, S1. Okay, so S1 is equal to 0 is the equation of this tangent drawn to this parabola at a point x1 comma y1 is S1 equal to 0. You know the meaning of S1. S1 means for this parabola y1 minus 2a of x plus x1 equal to 0. So this is the equation of this parabola, equation of the tangent of this parabola drawn at a point x1 comma y1. Right? Suppose now, see this, write a condition for a line y equal to mx plus c to be a tangent of y square equal to 4ax. Okay, so this is okay graph of y square equal to 4ax. So now I gave you tangent equation y equal to mx plus c. We have to write a condition for this line to be a tangent of this parabola. See, for that, so I am taking this point of contact as x1 comma y1, x1 comma y1. So you know, just now we read when the point of contact is given, okay, how to determine the equation of the tangent. So equation of the tangent is equal to s1 equal to 0, no? Right, apply this formula so that you will get y1 minus 2a of x plus x1 is equal to 0. Now arrange all the terms of this equation in standard form. Standard form is first you have to write x term, 2ax will come, and here minus y1 plus 2ax1 which is equal to 0 will come. Simplify this and express all the terms in standard form of the line. So in which we will get first term x, ax plus by plus c equal to 0, no? I arranged the term like that. And here actually what is this? It represents the tangent equation of this. Okay, but whose equation is given in the problem? What is that? mx plus c. Even for this also arrange all those terms in standard form. So here you will get mx minus y plus c equal to 0. Both are representing same line equation. Hence, so whose corresponding coefficients are proportional, no? Now take that proportionality for these two line equations. Here x coefficient 2a, here x coefficient m, 2a by m. Here y coefficient minus y1, here y coefficient minus 1. Here 2a x1 by c. Minus minus cancel. So equate these two. So again equate these two. 2a cancel. So when you take these two, so your x1 will be how much? Students, here 2a cancel, take the c left side. C by m come. C by m will come. If you equate these two, minus minus cancel, y1 will become, so 2a by m. Okay. So this is a point of contact. What is that? C by m comma 2a by m. But where is this point? On the parabola, no? In the next step I am going to replace x, y by this point, because this point is there on the parabola as well as line. So substitute this point either in the parabola or in the line equation so that you will get one condition. So now I am substituting in parabola equation. So here, if you write there 2a by m whole square which is equal to 4ax, x means what? C by m. Now simplify. 4a square by m square which can be written as m into m. Now 4ac by m. Now m cancel. 4 cancel. Now a square can be written as a into a by m which is equal to a into c. A also cancel. Now what is left? C is equal to a by m. So this is the required condition for that line y equal to mx plus c to be a tangent of this parabola. Okay. So now c is equal to a by m. Now go back and wherever c is there in this point of contact, write there a by m. If you write here in the place of c a by m, then this point of contact will become a by m square. Am I right? So substitute c equal to a by m square comma 2a by m. Okay. So here we got condition c equal to a by m and we got point of contact coordinates a by m square comma 2a by m. Right. See y square equal to 4ax, and here we have drawn a tangent whose equation is y equal to mx plus c. But c is nothing but a by m we have got now. So what is this? Slope form of a tangent equation. It represents equation of this tangent in slope form. Okay. So you know, from exterior point to the parabola, how many tangents can we draw? One is this side, one more is this side, no? Both are intersecting at a point. Let us take this point coordinates as x1 comma y1. Okay, right. Now, can I substitute this point on this? Because both tangents are moving through P. So now P is also there on this line. Hence, I am replacing here x and y by this x1, y1. So that what I will get? y1 is equal to mx1, so plus a by m. Okay. Now, take here, simplify. If you simplify here, y1 is equal to m square x1 plus a by m you will get. So, in the next step, take cross multiplication and express in the standard form. M square x1 minus my1 plus a, which is equal to 0 you will get. Observe this, x1, y1 is a fixed point, means constants. And here you got a quadratic equation in terms of m. If you solve this, you will get two values for m. One m represents slope of this tangent, one more m represents slope of this tangent. Let us assume this point of contact as a and b. Okay. Now what is the sum of the slopes? m1 plus m2 is equal to difference of, m1 plus m2 equal to minus b by a, minus here b value minus y1. So that here you will get y1 by a value x1. Sum of the slopes, because it represents a quadratic equation in terms of m. You know, sum of the roots alpha plus beta equal to minus b by a. If you apply that, here you will get y1 by x1. Product of the roots m1 into m2 is equal to here a by x1 you will get c by a. Product of the slopes of these two tangents is a by x1 and sum of the slopes y1 by x1. Suppose if the angle between these two tangents is 90 degrees. Okay, if you take angle between these two tangents is 90 degrees, then these two lines are mutually perpendicular, no? If these two are perpendicular, you know, product of their slopes is equal to minus y1, minus 1. So if you write here in the place of m1, m2 minus 1, so then it will become a by x1. So if you take cross multiplication, minus x1 equal to a. Now x1 equal to minus a. But it is a locus point. This p can be anywhere here. Replace this x1 by x equal to minus a. What does it represent? Equation of directrix of this parabola. Am I right? Equation of directrix of this parabola. So here, this will be the directrix for this parabola, no? That is x equal to minus a. Or if you take here minus a left side, x plus a equal to 0. Okay? By observing this, what you people are understanding? So, where these tangents are intersecting perpendicularly on the directrix of this parabola. Okay? So, actually for this parabola, you can able to draw infinitely many tangents. At every point on the parabola, you can draw one tangent. But among all the tangents, some tangents will be intersecting 90 degrees to each other outside. Where they will intersect? On the directrix. Okay? So, where do we get the point of intersection of perpendicular tangents drawn to this parabola? On the directrix. What is the equation of the directrix? of this parabola x plus a is equal to 0. You know, we get a from here. Okay, right. Even you can say like this also. On the directrix there are infinitely many points now. So if you draw pair of tangents from any one point on the directrix to this parabola, then which will be perpendicular. Pair of tangents drawn from a point on the directrix to this parabola are perpendicular. Okay, right. Next, see here. Find the angle between from this exterior. We can draw two tangents. Okay. So name of the parabola y square equal to 4ax, and let us take this p coordinates x1 comma y1. Here what I am asking you, determine the angle between the pair of tangents drawn from p to this y square equal to 4ax. Let us take this angle be theta. How do you find this angle? So you know, when you know the slopes of these two tangents, you have this formula to find the angle between the tangents. So m1 minus m2 by 1 plus m1 m2. Okay, right. So students, tell me, m1 m2, how much have we got in the previous one? m1 m2 is equal to a by x1 you have got. Okay, but difference of slopes we don't have. Product of the slopes we wrote as a by x1, and sum of the slopes we have written, but you don't have difference. You have to prepare difference of the slopes. So for that you have this formula, m1 minus m2 is equal to square root of m1 plus m2 whole square minus 4m1 m2. Okay, so apply that formula. So that what do you get here? Difference. So sum of the slopes, just now we wrote y1 by x1. If you write here y1 square by x1 square minus 4 m1 m2 a by x1. Now simplify this. If you simplify, you will get root of y1 square minus 4a x1 by x1, and this is m1 minus m2. Now substitute in this tan theta formula. So difference of slopes is equal to y1 square minus 4a x1 by x1. So in the down, so 1 plus here m1 m2 a by x1. So if you simplify this, take cross multiplication, this x1 get cancelled, and you will get this one. See here, y1 square minus 4a x1 by a you will get, sorry, a plus x1. A plus x1. So you know y1 square minus 4a x1 is nothing but root s11 by x1 plus a. Here you can use the mod symbol to get the acute angle. Okay, right. Now, okay, what is the angle between the pair of tangents drawn from P to the parabola is tan theta is equal to root s11 by x1 plus a. If you want theta, send tan theta to the right side, so that you will get tan inverse of s11 by x1 plus a, root s11. No? Okay, right. Next. Suppose if the parabola is in this form, y square equal to 4a of x plus a, y square equal to 4a of x plus a. In the previous one, okay, parabola equation was y square equal 4ax. Suppose if the parabola equation is given in this form, then slope form of whose tangent will be same like y equal to in the previous one what we have got mx plus mx plus c means a by m you got, no? So wherever x is there, okay, what we have got here x plus a, same thing should be written over here, y equal to m of x plus a, which is plus a by m will be the slope form of this tangent. Okay students, see, if parabola equation is given as y square equal to 4ax, then what will be the slope form of the tangent? Y equal to mx plus a by m. But instead of x here, what is given in the parabola? X plus a. Even this represents also a parabola. But whose center is, whose vertex is not 0, 0. Okay, whose vertex will be minus a, 0. Observe this. If the vertex is minus a, 0, then whose tangent slope will be in this form? Y equal to m. So here, easy to remember, in the place of x, x plus a is came. So same thing should be written over here. In the place of x, what we have tried? X plus a. Y equal to m of x plus a by m is the slope form of the tangent for this parabola. Right. Right. Now students, see one more thing. So suppose, okay, if the parabola is y square equal to 4ax and the tangent equation is given as lx plus my plus n equal to 0. In the previous one, the tangent equation was y equal to mx plus c. Now it is given as lx plus my plus n equal to 0. In this case, write the condition for this line to be a tangent of this parabola and also find the point of contact. Now what do you do? So same, however we have done for the previous one, same procedure should be applied to this. Let us consider this point of contact as x1 comma y1. So when the point of contact is given, how to determine the tangent equation, you know. How do you find tangent equation? By applying this condition s1 equal to 0. Apply that y1, so minus 2a of x plus x1 which is equal to 0. Now arrange the terms in standard form. 2ax minus y1 plus 2a of x1 which is equal to 0. Okay students, right. So but see here, in the problem they gave tangent equation as lx plus my plus n equal to 0. But both the equation represents the same tangent equation. Hence, whose coefficients are proportional. So 2a by L, now which is equal to minus y1 by m, so which is equal to 2a x1 by n. Now equate these two so that you will get y1 as minus 2am by L. Now equate these two. On equating these two, 2a cancel. Now x1 is equal to, so what we are getting? N by L. Now point of contact coordinates are n by L comma minus 2am by L. N by L comma minus 2am by L. Okay, to get that condition, so that point must be substituted either on this line or in the parabola. So this point is there on the parabola as well as in the line. Now I am substituting this point in the parabola. So if you write here, your y square is there. Take the square of this. So 4a square m square by L square. Now which is equal to 4a x. X means n by L. Now here 4a square I am writing as 4a into a m square by L square I am writing as L into L. So which is equal to 4a into L, 4a n by L. 1L cancel, 4a cancel. Now what is left? AM square is equal to NL is the required condition for this line to be a tangent of this parabola. Okay na? Right. Next time, see here. Suppose if parabola equation is given like this, x square equal to 4ay. Now I have changed the parabola whose equation is x square equal to 4ay, whose axis is y axis. For the previous one, axis of that parabola was x axis, but for this y axis, you know. So now same question, write the condition for this y equal to mx plus c to be a tangent of this parabola. Okay, for this what you need to do, same procedure we have to apply, same like previous one. So first we have to assume this point of contact coordinates as x1 comma y1. Now equation of this tangent, how do you get? S1 equal to 0. For this, what is S1? x1. Now take the half of y coefficient. 2a of wherever y is there you have to write y plus y1. Now arrange all these terms in the standard form. X1, when you bring this one left side, minus 2ay minus 2ay1, which is equal to 0. Now express all the terms of this equation in standard form. Mx minus y plus c equal to 0. Both are representing same tangent equation, hence coefficients are proportional. So x1 by m, so which is equal to minus 2a by minus 1, which is equal to minus 2a y1 by c. Okay, now equate these two, so that what do you get? X1 minus 2am. Your point of contact x coordinate is minus 2am, comma. So when you equate these two, minus minus cancel, 2a cancel. So now your y1 will be y1. Equate these two, minus minus cancel, 2a cancel. Y1 is equal to minus c. You will get minus c. Minus c. Point of contact coordinates you have got. Okay, right. Now to get the condition, what you quickly have to do? The point of contact must be substituted in this parabola. So here x square means here 4a square m square you will get, which is equal to 4a y means minus c. Now simplify. 4a square can be written as a into a m square minus 4ac. 4a cancel. Okay, multiply on both sides with minus. C is equal to minus am square. So this is our required condition. Okay, C is equal to minus am square. Now replace this C by this minus am square, so that your point of coordinates will become minus 2am. On writing, okay, C is equal to minus am square here. So then it will become plus am square will come, but because there minus, here minus, minus into minus plus. So this is our point of contact. Okay, and C equal to minus am square is our required tangent, required condition for this line to become tangent of this parabola. Okay, right. Next, see here, I am taking two parabolas. Observe those two parabolas. X dash, y dash. Right? This is y square equal to 4ax, and this one is x square equal to 4by. I want common tangent equation of both parabolas. Okay, find the equation of common tangent of this parabola and this parabola. Okay, see how I am going to find it. See students, Okay, for this parabola, what is the slope form of the tangent? Y equal to, so for this, y equal to mx plus a by m. Am I right? So, equation of this tangent with respect to this parabola is y equal to mx plus a by m. But this is also a tangent of x square equal to 4by, no? So that what I am doing here, this x square is equal to 4b. Okay. So in the place of phi, I want to write this one. mx plus a by m. Because this is also a tangent of this, no? Hence, what I am doing, I replace y by this. Next, what I am going to do? I am going to simplify this. We will get a one quadratic equation. For that quadratic equation, I am going to apply delta is equal to 0. Because I would like to find the value of m. So you know that tangent equation of y square equal to 4ax, y equal to mx plus a by m. Okay, if you know the m value, then you will get equation of that common tangent. Because the tangent was common to both parabolas. So there we do not know the m value. To get that m value, what I am doing? So first I took the tangent equation for the y square equal to 4ax. What is that? Y equal to mx plus a by m. Okay. So that one I have substituted in the second parabola, that is x square equal to 4by. Next I am simplifying. If I simplify this, what I will get? A quadratic equation in terms of x. And for that I will apply delta is equal to 0. Okay. Right, now simplify. X square equal to 4b mx plus 4ab by m. Okay, bring all those terms to the left side. X square minus 4bm or 4mb x minus 4ab by m, which is equal to 0. Now for this, what do you apply? Delta equal to 0, because that is a tangent to the second parabola also. Hence we know discriminant value of this quadratic equation becomes 0. Apply that. So here b square means 16 m square, b square you will get, b square minus 4ac minus 4, a value 1, c value minus 4ab by m. So which is equal to 0. Now simplify this. If you simplify, what do you get? So here 16 m square b square, this minus into minus plus. So 16 ab by m, which is equal to 0. So in the next step, so take cross multiplication. 16 m cube. So here 16 m cube b square plus 16 ab by m, which is equal to 0. Now transfer m to the right side. 0 into something 0. From the numerator take b common. 16b common. So here what is left? M cube b. Here what is left? 16b went outside, a left, which is equal to 0. Now transfer 16b to the right side, which will come as 0. Hence, so your m cube is equal to minus a by b. Now m is equal to minus a by b whole power 1 by 3. Okay. So now substitute that m value minus a by b whole power 1 by 3 in y equal to mx plus a by m. Okay, that is our common tangent now. Y equal to mx plus a by m. So in the place of m, write this y equal to, so minus a by b whole power 1 by 3 into x plus a by m. M means minus a by b whole power 1 by 3. So you know, here minus power odd number becomes minus. Minus a power 1 by 3, b power 1 by 3 you can write x. Here minus power odd number becomes minus, plus into minus minus a. So here a power 1 by 3, b power 1 by 3. b power 1 by 3 will go into the numerator by a power 1 by 3 will come here. Okay. In the next step, what I will do? So see students, I would like to send here a power 1 by a power 1 by 3 is there. A power m by a power n equal to a power m minus n. So now simplify this. So here y is equal to a power minus a power 1 by 3 by b power 1 by 3 into x. Here a power 1 minus 1 by 3 into b power 1 by 3 whole by 1. So now simplify that. So what do we get if you simplify? Y equal to minus a power 1 by 3 by b power 1 by 3 x. So a power 2 by 3 into b power 1 by 3 whole by 1. The LCM of these two is y equal to minus a power 1 by 3x. So when you take cross multiplication here, a power 2 by 3 and b power 1 by 3 into b power 1 by 3, b power 2 by 3 whole by b power 1 by 3. Bring it to the left side. So that what do you get? Y into b power 1 by 3, which is equal to minus a power 1 by 3x minus a power 2 by 3 b power 2 by 3. So when you bring these two terms to the left side, so you will get a power 1 by 3x plus b power 1 by 3y plus a power 2 by 3 b power 2 by 3, which is equal to 0. So that is our required common tangent equations of y square equal to 4ax and x square is equal to 4by. Now my next question is, find the common tangent equation of x square plus y square which is equal to 2a square and y square equal to 4ax. Find the common tangent equation of these two. So you know it represents a circle equation, it represents a parabola. So here now draw the circle equation. Here it represents a circle having center origin no. So here x dash, y dash. So if you draw this, you will get the parabola like this. So for both parabola and circle, we need to find a common tangent. It may touches both curves at these two distinct points. So whose equation we have to determine? This represents this curve equation. This represents this curve equation. For both curves, what we need to find? Common tangent. You know, okay, for this parabola, what is the equation of tangent? Y equal to mx plus a by m. And this is also a tangent of the circle, no? So if it is a tangent of the circle, you know the condition. So what is that? R equal to D. R means radius of the circle, no? So what is the radius of this circle? X square plus y square is equal to 2a square. I gave the 2a square. I would like to write as root 2a whole square. Means here we are getting radius as root 2a. Now D means what? Perpendicular distance from center to this common tangent. R you got root 2a. So now perpendicular distance from center 0, 0 to this line. So express this line in standard form mx minus y plus a by m, which is equal to 0. Now D is how much? Students, see here 0, 0. You know the perpendicular distance from a point to the line. D is equal to mod ax1 plus by1 plus c by root a square plus b square. But here x1 y1 0. Hence here we will get perpendicular distance a by m by root a square plus b square, m square plus 1 you will get. Okay. Now square on both sides. So that what do you get here? 2a square. Now here a square by m square of m square plus 1. Now a square gone. Now take cross multiplication so that you will get 2m power 2m square of m square plus 1, which is equal to 1 you will get. Now simplify this. 2m power 4 plus 2m square 2m power 4 plus 2m square minus 1 which is equal to 0. Okay, now solve this. So if you solve this, what do we get? So 2m square, 2m power 4 plus here 2m square is there. So 2m square how do we solve this? For which value of m it is going to be true? So m is equal to 2m square. Split it. Sorry. Okay. See here. Okay. Here I am changing this parabola equation. Parabola is not y square equal to 4ax. Take this parabola as y square equal to 8ax. Y square equal to 8ax means, so okay, compare this one with the standard form y square equal to 4ax, but in the a place we get 2am. Observe this point. I am changing the parabola equation because here we are not getting m values. So here change this okay, 4a as 8a, so that here we will get a value 2a. You know this condition, y equal to mx plus a by m for y square equal to 4ax. But here 8a I am giving you, so that your a will become 2a. If you take there 2a, so here see, apply r equal to d. No changes will come in the radius, root 2a only will come. But here while finding the okay, perpendicular distance from origin to this line, here little changes will come. So 2a by m mod of 2a by m whole okay, by root m square plus 1 number. Now take the square on both sides. So here 2a square will come. 2a square is equal to, so here what do we get? 4a square by m square of m square plus 1 you will get. So now a square gone, 2 ones are 2 twos are. Now m square of m square plus 1 which is equal to 2 you will get. Now simplify this, m power 4 plus m square minus 2 which is equal to 0. Okay, now solve this. So if you solve, okay, here I am splitting the middle term as 2m square minus m square minus 2 which is equal to 0. Alright, from these two take m square common, here m square plus 2, from these two take minus 1 common, m square plus 2 which is equal to 0. Now here m square plus 2 into m square minus 1 equal to 0. So this is not equal to 0 because here positive plus positive is there. Hence equate this one equal to 0. You know, product of two expressions equal to 0 means either this should be 0 or this should be 0, both of them 0. I am taking this one equal to 0. So that what I will get? M plus 1 into m minus 1 which is equal to 0. Now our required m values will be either minus 1 or plus 1. Minus 1 or plus 1. So substitute that m equal plus or minus here. So that what do we get? Our required common tangent equation, y equal to plus or minus x. I am replacing m by plus or minus x. So here also plus or minus 2a. So from both if you take plus or minus common, so x plus 2a means our common tangent we may get this side or we may get this side. Both common tangents are possible. Okay, these are our required common tangents for this parabola y square equal to 8ax and this circle y x square plus y square which is equal to 2a square. Right? Now see students, next let us go to okay, parametric form. So equation of the tangent in parametric form. So in my previous classes also I taught to you, see, angle between these two parabolas. Remember this one also. See here, y square equal to 4ax, and this is if you take this parabola as x square equal to 4by, both will intersect at 2 points, here and there. Here angle between them is 90. Here angle between them is, so you know how the angle will form between the two curves. Wherever those two are intersecting, there we have to take tangents. Angle between the tangents is equal to angle between the curves. How much angle do we get for that? Tan inverse of, so 3a power 1 by 3, b power 1 by 3 by 2 of a power 2 by 3 plus b power 2 by 3 is the angle between these two parabolas. So what is that angle? Tan inverse of 3a power 1 by 3, b power 1 by 3. 2 of a power 2 by 3 plus b power 2 by 3. If the parabolas are given, y square equal to 4ax, x square equal to 4by. Sometimes if a is equal to b, okay, here also if they write x square equal to 4ay, you have to replace a equal to b. If you write a equal to b, then theta will be tan inverse of here a equal to b. So if you write a equal to b, a power 2 by 3 you will get. By if you write here a equal to b, so you will get 2a power 2 by 3, means 4 a power 2 by 3 you will get. So a power 2 by 3, a power 2 by 3 you will cancel, you can cancel. Now angle between them is tan inverse of 3 by 4 you will get at this point. You know, we have proved this one in the previous classes. Okay, but just you remember like a standard result. What is the angle between these two parabolas? Tan inverse of 3 of a power 1 by 3, b power 1 by 3 by 2 of a power 2 by 3 plus b power 2 by 3. Suppose if a is equal to b, then you will get tan inverse of 3 by 4. Okay, right. Next, let us go to the equation of the tangent in parametric form. Okay, see, you know, so y square equal to 4ax. Now let us assume that point in the parametric form as at square comma 2at. So students, what you have to do? So you know the point of contact, but you don't know the slope of the tangent. So differentiate that. 2y into dy by dx, which is equal to, so 4a you will get. Now let us represent this dy by dx as m. Now 4a by 2y. Now m is equal to 4a by 2 into y. Y means 280. So 4 cancel. A cancel. What is left? 1 by t is the slope of this tangent. Now you got the slope. Now you know the point. Now apply the point slope form of the line equation. So that what do you get? Y minus y1 280, m value 1 by t, x minus x1 at square. So take this t left side, yt minus 2at square. So x minus at square. Now yt, when you bring this on right side, so that you will get here x plus, both are like terms, at square you will get. Okay, so yt, which is equal to x plus at square, is the equation of the tangent drawn at this point, at square comma 280. Remember like a standard result, yt which is equal to x plus at square. So suppose if the tangents both are drawn at two different points, one is drawn at here, one more is drawn at here. Okay, so now let us assume these 2 points as at1 square comma 2at1, and this point at2 square comma 2at2. So what is the equation of the tangent drawn at this point? So here replace t by t1, y(t1) which is equal to x plus at1 square. What is the equation of the tangent drawn at this point? y(t2) comma x plus at2 square. Okay, if you solve these two, you will get this point. Am I right? So how to solve the linear equations in two variables, xy, you know. Solve it by substitution method or elimination method. Okay, you know how to solve the linear equations in two variables. Solve them so that you will get this point of contact as a t1 t2, which is equal to a of t1 plus t2. Okay, so what is this? Point of intersection of these two tangents drawn at this point and this point. How do we get? So two tangent equation we prepared. By solving these two, you will get this point. Remember, like a standard result, a t1 t2 minus a of t1 plus t2. t1 is the parameter for this point, t2 is the parameter for these 2 points. Okay, students? Right. Suppose if these two, okay, these two tangents are mutually perpendicular. Mutually perpendicular means what is the slope of the first one? 1 by t1. What is the slope of second one? 1 by t2. Now you know m1 into m2 is equal to 1 by t1 t2. But for the perpendicular lines, product of their slopes equal to -1. Now 1 by t1 t2. Now t1 into t2 is equal to -1 you will get for perpendicular lines. Means if these two tangents are perpendicular, you will get t1 t2 equal to -1. So in that case, point of intersection will become here, right? -1. So that here you will get -a comma a of t1 plus t2. Okay, right. You know, these two tangents are intersecting perpendicularly on directrix, whose equation is x equal to -a. Next, students, here you have to remember two more points. See this, x, x dash, y, y dash. Okay, take a focal chord. Take a focal chord. Okay, this is focal chord. The chord which passes through focus is known as focal chord. Now if you draw the tangents at extremes of the focal chord, so which will intersect on directrix perpendicularly here. This is the tangent drawn at this end of the chord. This is focal chord. At one extreme I have taken a tangent, and this is one more extreme of this focal chord where I am taking tangent. These two tangents will intersect at 90 degrees to each other on directrix. This is the equation of the this is directrix of this parabola, whose equation is x equal to -a. Okay, if you draw the two tangents at extremes of the focal chord, then which will intersect at 90 degrees to each other on the directrix. Okay, right. Observe this point. Next, x, x dash, y, y dash. So here I am taking a parabola y square equal to 4ax, and here I am taking directrix, whose directrix. Take any one point on directrix and take any one point on the parabola. So connect these two. Let it be A and let it be B. So this is the intercept between the parabola and the directrix along with this line. So this AB line segment will make 90 degrees angle at the focus. Okay students, remember this point. AB is the intercept between the parabola and the directrix along with this line. Okay now, actually what is this? Tangent. So here tangent is moving like this. This AB is the intercepted by the parabola directrix on the tangent. This portion will make how much angle at the center? 90 degrees. How much is this? 90 degrees. Remember that point. So where it will make 90 degrees? At the focus of this parabola. Next, see here, it is one parabola. Okay, right? Now I am taking focus here. Focus. Let it be yes. Here I am taking a tangent. Okay, shall I name it as P? Yes. So, shall I take it as Q? Q. Where I am taking a tangent. So, two tangents I have drawn to this parabola. Y square equal 4ax or any other parabola. Two tangents are intersecting at this point. P, Q, let it be R. Okay. Then, see students. So, SP square, here you have to remember one point. SR square, which is equal to SP into SQ. Okay. So, students, both tangents are intersecting at R. What is this here? Focus of this parabola. P and Q are points of contacts. These two tangents are meeting at RR. Then this SR square is equal to SP into SQ. Remember this point. SR square is equal to SP into SQ. And if we connect SP and QS, okay, so these two angles will be equal. This RQ is making some angle at the S, no? This PR making some angle at the S, no? These two angles are equal. Angle RSP, which is equal to angle RSQ. Both angles are equal. And both triangles are similar triangles. SQR plus students, these two angles are equal, no? SRQ. SRQ. Triangle SRQ is similar to triangle SRP. Okay, here you have to remember 3 points. This is a parabola, focus, two tangents are drawn, meeting the two tangents at R. Then SP square, SR square is equal to SP into SQ, this point. Next to this RQ will make one angle at the center, no? That angle is equal to angle made by this PR at S. These two angles are equal. And this triangle and this triangle, both triangles are similar triangles. Okay students, last point, you know already you learned this point in the circles. So here one exterior point is there, that is P, whose coordinates x1 comma y1, and here this is A and B. From P to B we can draw two tangents. From exterior point to the parabola, how many tangents we can draw? Two tangents. Now my question is, write the combined equation of P and PB. How do we get that combined equation? Means pair of tangents drawn from exterior point to this parabola S equal to 0 is S1 square is equal to S into S11. So if you apply this, what do you get? Pair of tangents drawn from exterior point P x1 comma y1 to this parabola. Okay, thank you.